Morning all. This is Bhatmapriya from Information Technology in SNS College of Technology. So today we are going to discuss the topic about process scheduling and synchronization in Unit 2 of operating systems. Under this concept, we are going to see the topic about deadlock. Uh, Generally, before to enter the session, we just make a recall for the previous session. So the last session we have discussed about process compete for limited resources and improper sharing leads to issues. Deadlock is a major problem. So that's why we are going to discuss about what is deadlock. So the topics for discussion is system model, deadlock characterization, handling deadlocks, deadlock prevention. So these are all the things we are going to discuss, and let's explore the concepts about the process before we enter the deadlock. Process request resources. Resources are held by others and systems get stuck. This is the reason for deadlocks. Why deadlock matters means process stop executing, resources remain unused, system efficiency drops. Here, process P1 is resource 1 is assigned for process P1, and at the same time process P2 requests the same resources 1, but the resource 2 is assigned for P2, but the P1 is request for resource 2. So this is the thing which is happened while a single resource can requested by the other process at the same time. So due to this issue, the resources remains also unused, and system efficiency also will drop. So process waits forever. Each holds some resources waiting for others to release. So here uh, the same resources can requested by two process means the resource can assigned for the first process. The other process should wait until the first process complete the process. Uh, then after once the first process complete their task, then it will release the resource 1. Then again the resource 1 can allocate it to the another process which is already requested. So resources are finite. Process request and release resources. Deadlock occurs during allocation. So this is the deadlock characterization, and here deadlock happens only when conditions hold. Four necessary conditions are there for deadlock characterization. All must be true for deadlock. Here allocated resource 1 for process 2, and the resource 1 is same requested by process 2, and the process resource 2 and 3 is allocated for process 2, but these resources are requested by process 1. So the necessary conditions are mutual exclusion, hold and wait, no preemption, circular wait. These are all the necessary conditions for deadlock. Methods for handling deadlocks are deadlock prevention, avoidance, detection and recovery, ignore the problem. Deadlock prevention is we have to find the reason why deadlock happens. Deadlock avoidance means we are going to use some algorithms to avoid the deadlocks. Once we avoid the deadlocks after the process initiation, we have to check and detect either deadlock is happened or not. If it is happened, we have to recover the thing, or else we have to ignore the problem. These are all the methods we are going to handling the deadlocks. And this is deadlock prevention. Ensure one condition never holds. Restrict resource request. Avoids deadlock completely. So this is deadlock prevention. Um, we have to ensure one condition should not hold by any other thing for the long time. And the second one is resources request should be limited thing, and we have to avoid deadlock completely. So prevent mutual exclusion, make resource shareable and not always possible. Some resources must be exclusive, which means resource should be shareable by one or two process, and it should not always possible. While if it is possible for two process can use the single resource means uh, clash may occur. So some resources must be exclusive. So this is request all resources at once or released before requesting low utilization risk. So prevent no preemption means preemption resources if needed used selectively for the process which is needed a preemption and limited applicability. So this is the prevent circular weight. The real world application is here for deadlock. And let's summarize the topics. Deadlock stops progress and four conditions cause deadlock. Prevention avoids deadlock. So thank you.